Lesson 7.6 is on finding probabilities of compound events. So probability, it's like, what's the chance of this happening? So if you look at this on 391, Talia is playing a game in which she must choose option 1 or option 2. Then spin the game wheel, flip a coin, and then roll the number cube labeled 1 through 6. For her to win the prize, all the conditions listed under the chosen option must occur. Which option should Talia choose and explain? So for option 1, the game wheel has to land on an S, the coin has to land on tails, and she has to roll an even number. For option 2, in order for her to win, the game wheel has to land on a Z, a coin can land on either side, and she has to roll the number 3. So if we look at these different options, what we can do is look at their probabilities, their chances of them happening. And basically, probabilities of compound events, what we're going to do is we're going to find the fraction probability of one of the things happening, and then the next thing happening, until we've done all the things that's going to happen. And then if we multiply those fractions together, that is going to be the probability of the compound event. Okay, so this may not be relative to people listening to this video, but currently, when I'm recording this, we had just looked at the Final Four of the basketball tournament and looking at, how many, just different options, picking different options, and then we're going to talk about what the chances are that someone correctly picked the last 2 games correctly, winning their first game, and then who won the championship. So we can talk theoretically what that probability is, and then we can look at, in our experiment, what people actually chose. So on the wheel, for option 1, we want to get an S. There's actually only one S on the whole wheel, and there's a total of 15. Looks like more than that, but anyway, there's only 15. So landing on an S, probability of landing on an S would be 1 out of 15. Next, for flipping a coin, landing on tails is a half chance, 1 out of 2. And then finally, rolling an even number, we can think about our options are 1, 2, 3, 4, 5, and 6. The even numbers would be 2, 4, and 6. So that's 3 out of the 6 different choices, which you can reduce if you'd like to 1/2. So like I said, for a compound event, finding the probability, we're just going to multiply those fractions together. That's going to tell the overall chances of this happening. And again, the more things you have to have happen, the more different events there are, the less likely it's going to happen. Okay? So for example, if we are picking for the bracket for the 64 teams, all their games, and trying to pick a perfect bracket, that's a lot of games.
That's a 1 out of quintillion.
So if we multiply these together, 1 times 1 times 1 is 1, and the denominator 15 times 2 is 30, times 2 is 60. So that'd be a 1 out of 60 chance of winning with that option. So for option 2, if we do a similar idea, we first want to get the wheel to land on a Z. Probability of landing on a Z would be a 1 out of 15. So the next option, with the coin landing on either side, it's always going to land on either side. Okay, you could argue, there's people argue this every year, what if it landed on the side and not heads or tail? It's not going to happen. Okay, so this would be actually, you could just say a 1 or a 1 out of 1. If you want to say 2 out of 2, heads, tails. Okay, 2 out of 2 chance, same thing, but it's definitely going to happen. So the chance of rolling a 3, finally, there's only 1 3 out of 6. Sometimes by the number being there, people get confused sometimes and put 3 out of 6, but just remember there's only 1 3. Okay, there's only 1 out of the 6 options. All right, so at that point we can multiply these together. Once again, 1 times 1 is 1 times 1 is 1, and if we multiply our denominators, 15 times 1 is 15 times 6 is 90. So there's a 1 out of 90 chance for option 2. Option 1, there was a 1 out of 60 chance. So actually, option 1 gives her the better chance of winning. A lot of people might look at that and, just by the face value of looking at the question, you might think, oh, well, the coin can land on either side. That's always going to happen. So I think definitely she's going to have a better chance with option 2. The problem comes in is that rolling the number cube, they're only giving us 1 option that actually works, whereas the other one, they're giving us 3 options that work. So it's just a lot less chance of rolling a 3 than rolling an even number, and that kind of counteracts that, and that's why option 1 actually is more probable. So the bottom of the page, suppose an option 3 was added with the conditions the game wheel lands on a Q, coin lands on either side, and an odd number is rolled. Should Talia change her choice to option 3 and explain? Sometimes when you do these problems, it'll say like P for probability and then in parentheses the different conditions. So if there's more than one condition, it will have commas usually separating them. So it might say probability Q, comma, either side, comma, odd. Okay, could be a way we could write that. So on the wheel, probability of a Q would be 1 out of 15. Probability of either side, again, would just be 1 or 1 over 1 if you'd like. And then probability of an odd would be 1/2. 3, 6, 3 out of 6 that are odd. Just like earlier, we had 3 out of 6 that were even. And then if we multiply those, 1 times 1 times 1 is 1. 15 times 1 is 15. 15 times 2 is 30. So that would be a 1 out of 30 chance. And so at that point, we would notice that this is actually going to give her a better chance. So we would say, yes, she should change to option 3 because 1/30 is higher than the other probabilities. So look at example 1. Sadie has 1 ticket left at the school fair, and she hasn't yet won a prize. She decides between 2 games. Which game should she play? So the options: flip to win, flip 2 heads to win a prize, presumably out of 2 flips, or flip and spin, flip a head and spin blue to win a prize. So what we can do is look at the different options, the different probabilities. So flip and win, the book went ahead and just listed out all the different possibilities, and you can see getting 2 heads is 1 out of 4 chance, or 25%. Another way you could have done that, you could have said chance of heads was 1/2, chance of the other heads is 1/2, and multiply is 1/4. Okay, either way is fine. And then flip and spin, they've listed out the options again. They wanted to get blue and heads, so blue and heads is 1 out of the 8 options, so that's a 1/8 or 12.5% chance. The other option you could say for blue, blue is a 1 out of 4 chance, heads is a 1 out of 2. and then multiply those would be 1/8. So you can see from that, obviously 1/4 is more than 1/8. So she should do the flip to win again, because 25% is more than 12.5%. She has twice the probability of winning in that game than the other one.